Hello everyone. So today we are going to start this data link protocol. This data link protocol is in second part of your digital data control. Digital data control. So this is in second part of it. So here we are going to see this some data link control protocols. So here there's a data link control protocol. It works in as a data link layer. No? From the physical layer we will get as a data and we are transferring to as a data link layer. This data link layer will control this all the protocols. So coming to this data link control protocol, it's going to be responsible for the implementation of point-to-point view, point-to-point view, and along with this a point-to-point view. So we have this error control mechanism. Error control mechanism. So coming to this error control mechanism. Right. So here we have some functionalities for this data link control. What is this functionalities means here? One is in data link control, another functionality is in media access control. Media access control we can already call them as an up to shape link, up to shape link. And this data link control coming to as a data link control. So this data link control, so it has an deals with the designing and procedure of the communications between the two adjacent nodes. Between this two adjacent nodes, that's we call them as a node-to-node communication. Okay, so these are the two functionalities of your data link control protocol. So coming to this, what is the need of data link control here? And thus, so what is the need of this using this data link control in the digital age? So we'll see this data communication. Need of data link control. One is on frame synchronization, flow control, error control, addressing, control and data on same link management. So we are having these parts, these type of needs for your data link control. Coming to this frame synchronization. This is a frame synchronization here. It's going to be beginning and ending of the frames. Whatever the data we are taking, that will be set as a frame. That will be called as a frame. So the beginning and end of the frame must be recognizable. Okay. So coming to this flow control. Second, this flow control is going to be mentioning this. The sender should not send it faster than the receiver's capacity. The sender should not send as a transmitter faster than the receiver's capacity. Okay, that's a flow control. So coming to this error control, here this error control is going to be controlled by the error correction or error detection. It's going to be transmitted, should be a corrected or it may be a digital. Coming to the fourth one, address. It's going to be addressing once it's going to identify as a sender or receiver. Okay, it's going to be mentioning there's a two stations or two transmissions. Coming to this control and there's a data on same link. Coming to this control and data on same link. No physical data or no physical separation of link is going to be shared or is going to be mentioning for the control and there's a data information. There is no any physical separation link for control and there's a data information. Okay, so coming to this link management. In this link management, it's going to be coordinating and cooperation of among the stations. So there should be a coordination and cooperation for the statements. For the statements. So here, there's a coordination and cooperation should be done in your information initiation, maintenance, termination of the sustained data exchanges requires an amount of coordination and cooperation between the stations. Okay, so here it's going to be responsible for the point-to-point view and there's a error control mechanisms, functions of your data link control, and there's a need of the data link control. Okay, so these are the data link control protocols. So here it's going to be responsible for the implementation of point-to-point flow control. It's nothing but a flow control input. Okay, so coming to this, we'll see there's a flow control. Okay, this is a flow control. Here, flow control is nothing but it enables a receiver to regulate the flow of data from the sender so that the receiver buffer does not flow. Okay, so I'll share you one example here by using in sender and receiver. You can see this, the sender has sends all the frames to the receiver. Frame 1, frame 2, frame 3, frame 3. So there is no any error. It's an error-free transmission we can directly send. Now I'm going to transmit another message. Here, when I was transmitting, I have two interrupts. One is in frame 2 and the another one is in frame 2. Frame 1, frame 3 and frame 5 was transmitted successfully. Frame 2, it was blocked. It lost its data in the middle of the transmission itself. So coming to this frame 4, it's going to be received. It received this data to the receiver with an error messages. With an error in the messages or error in the data. Okay, so it has an error in the data. Fine. So the frame which we are transmitting, so frame 2 and this is frame 4. Frame 2 has an error loss. Frame 4 has an error, data lost here. It's going to be error, it's going to be detected in this frame 4. This is the flow control. So when we are doing this a flow control, when we are doing this type of flow controls, so we have some controlling formats. So one is in two mechanisms we have for this flow control. One is in two types of mechanisms we have. One is in stop and wait, another one is in sliding window. One is in stop and wait, another one is in sliding window. So let us explore each and every part. Let us explore each and every part. So one is a stop and wait. So let us go through the stop and wait first. Stop and wait flow control. So coming to this stop and wait flow control. So it is responsible. It need to get this acknowledgement from the receiver. So I'll share you some sample here. The sender receiver is going to be transmitting as a data. That's a frame 0. The sender sends us a messages to the receiver and receiver sending the acknowledgement to the sender, that is an I have received your data with an acknowledgement of the frame number. Okay. After receiving the acknowledgement from the receiver, the sender is going to be sent another frame. That frame also review and send us acknowledgement or to the sender. So here what happens, the mechanism is forcefully forcing the sender after transmitting the data frame, it has to be stopped. Okay, it has to be stopped. Okay, so up to, it has to be wait up to the acknowledgement of the data frame will be sent is received. The acknowledgement of data frame is sent to be received. Okay, so these are the two mechanisms such as stop and wait flow control. The sender has to wait, stop and wait up to this acknowledgement as received from the receiver. Okay, this is stop and wait control flow control. So for that, so we have some drawbacks. One is when it has a delay or an acknowledgement of a data. Okay, so in this we have this two drawbacks. One is in losing of data, one is in loss of acknowledgement. When the sender sends the data to the receiver, it may be lost as a data. Why? Because for infinite amount of time, it has to be wait for the receiver to receive as a data from the sender. Coming to this loss of acknowledgement, the sender sends the data to the receiver. Receiver received as a data. Receiver sends acknowledgement to the sender. When the acknowledgement has sent from the receiver to the sender, receiver has shared already, but the sender is waiting for the acknowledgement of the receiver, with for a infinite amount of time. Okay, we can't able to predict whatever the time we have found. Okay, that's a lost main drawback. That's a losing of data and the loss of acknowledgement. There's a stop and wait flow control. Okay, coming to the second one, that's a sliding window flow control. Okay, so coming to the sliding window flow control. So it's an imaginary boxes. It refers to the imaginary boxes to hold frames, and also it allows multiple frames to transmit at a time. When we are transmitting the multiple frames, the sender will maintain as a list of sequence numbers to be allowed. The receiver has received and maintained as a list of sequence numbers which is prepared by the receiver. Which is prepared by the receivers. Okay. Here, when we are sending as a list, it's going to control the operations. It's going to control that is called as a sliding window flow control. Okay. And along with this, the sequence numbers, we are saying as a sequence numbers. Sequence numbers is used to occupy a field in the frame and it is limited to the range of values to be transmitted. Range of values to be transmitted. Okay, fine. So let us see with a small example to get clear understanding about the sliding window protocol. So example, sliding window. So here I have taken a 3-bit field. The sequence number can be arranged from 0 to 7. The 0 to 7 means it's accordingly the frame is numbered from modulo 8. To modulo 8, we have already gone through the sequencing numbers from 7 means it will be starts, the next number is starts from 0. The next number is starts from 0. Okay, so here for k-bit field, for a k-bit field, the range of sequence number is in 0. Okay, through 2 power k minus 1. And the frame of numbered modulo is in 2 power k. So minus 1 to power k minus 1 or 2 power k, modulo number. And there's a maximum window size is in 2 power k minus 1. Okay, and here, for example, I have assumed 3-bit sequence number so that the frame are numbered sequentially from 0 to 7. Then the same number are reused in the subsequent frames. Okay, so here when you are sliding it, you can see this the sender side perspective I have given. The sender has already transmitted this data from 0 to 7. So when he is transmitting, we have already mentioned this. 0 is a frame sequence number. Last frame transmitted is in 7. We have get the acknowledgement of up to the 5th last frame acknowledgement he has received for the 5th one. Okay. So the sender is waiting for the next frame to be transmitted. Next frame to be transmitted. Okay. So this is the sender side perspective. Coming to the receiver side perspective, receiver has received this all the frames, but he has sent the acknowledgement of fifth one. He is waiting for 6th and 7th acknowledgement. Okay. The receiver has also received this frame to be accept of 1 to 6 4. 1 to 4. Okay. The receiver are ready to be accepted. It may or may not be declared. May or may not be declared these particular elements. This is from receiver side. Okay. So this is a sliding window. So let us see the small example. Here there's a source A and there's a destination B. Here it was taken 0 to 7. Okay, starting window, ending window. So here the starting 3 windows I am sharing at a time, F0, F1, F2. So now my window has showed us 3, it has to be receiver. Receiver has to start from 3. 3, 4, 5, 6, 7, 0, 1. So this is my frame. So again it started from F3, F4, F5 and F6 it transferred. When it was transferring F3, the receiver has sending the receiver request as a 4. Okay, so it was transmitted this a receiver request as a 4. So after receiving this a 4, 5 and 6, the receiver has sent the request of 7. So the sliding window has transferred from 4 to 7 again. Now my window is from 7012. This is my 4-bit sequence windows 2. Okay, fine. So this is a small explanation about this sliding window protocol. So based upon this explanation, you have gotten clear understanding about sliding window. Okay. So these are the small explanation about the sliding window. So coming to this, what are the advantages of it means? It's a very much efficient and also a transmission link is treated as a pipeline. The transmission link which you will gain that is treated as a pipeline that will fill with frames and transit. Okay, that may be linked as a transmit. Okay, these are the two main advantages of using this sliding window protocol. It will be continuously pipeline. Okay, fine. So this is a clear explanation of your flow control, data flow control. The next topic is an error control. We'll see this error control in the next session or in next video. Okay, thank you.